Hello everyone, I am Dr.T.C.Mujeeburahman, Department of Mathematics, JJ College of Engineering and Technology, Trichy. Today we are going to discuss about calculus foundations, ordinary and partial differentiation. In this class we are going to discuss about the basics of differentiation. Importantly, we will start with limits, followed by continuity, ordinary differentiation and partial differentiation. In addition to that, we will be discussing about the examples along with the engineering applications. So, first and foremost, we'll start with limits and continuity. Limits and continuity is nothing but, this is the, before differentiating something, we have to understand what is limits and continuity. So, limits is nothing but, it is where the function approaches. The value where the function approaches is called the limit. The basic definition of limit is, a function f of x comma y is said to tend to the limit L as x tends to a and y tends to b, if and only if the limit is independent of the path followed by the point x comma y as x tends to a and y tends to b. This is the formula. Limit x tends to a, y tends to b, f of x comma y equal to L. This is the basic formula we are going to use in finding the limit of a function. So, next we'll look into the real life application of limits. So, from the word limit itself we can understand there are a lot of real life applications, not only mathematical, there are a lot of real life applications. One of the applications is, you have seen a car speedometer, right? In a car speedometer, there is a speed limit. It is nearly the same meaning, which means after gradually increasing speed, at some point of time we'll be reaching a particular limit. That is our speed limit, right? There we will use this limit concept. Next, in thermodynamics, when an ice cube is melting in a warm temperature, after some point of time, the temperature will be equal to the room temperature. That is the limit. Okay. Next, in chemistry, the amount of new compound formed after it comes to a stable environment. That is where this limit concepts are used in the real life applications. Next, these are some problems, practice problems of limits. This is how the problems of limits will be. Find the limit x tends to 3x plus y. What is the idea behind this is, what is the function value when x approaches 2? So here we are going to just substitute x equal to 2, which will give you what? 3 into 2 plus 5. So the value of the limit is equal to 11. Similarly, the next question is nothing but, what happens when the limit is x equal to 1? In this question you can solve like x square minus 1 divided by x minus 1, where we can split x square minus 1 as x plus 1 into x minus 1 by using the formula a plus b into a minus b divided by x minus 1, where we can cancel x minus 1, x plus 1. Now substitute x equal to 1, because that is our limit, which will give us what? 1 plus 1 is equal to 2. So this is our limit point. Understood? Okay. Next, we will move on to next, what is a concept of continuity? So the function of x comma y is said to be continuous at the point if it exists and at the point a comma b. From the word continuity itself we can understand that what? It is a function which is continuous in nature. In other words, we can say, like, if we are drawing a continuous graph, we should draw the graph without lifting the pen. Then that function is known as continuous function. Another example is discontinuous function, where there is some break or some jump happens in the function diagram. Okay, so that is the difference between continuous and discontinuous function. In simple words, you can say what? Continuous function is something that is smooth without interruptions. So if a function is continuous at all points of a region, then it is said to be continuous in that region. What is discontinuous? Which is not continuous, that's it. Okay, fine. So this is the diagram for understanding the limit and continuity. Limit exists at x comma y. So this is our limit point a comma b. So this is a pictorial representation of it. Next, what are the applications of continuity? Continuity application we are usually using in engineering, where the differential equations are imposing a continuity condition. Next, in a digital recording, where drawing the graph in a continuous manner. It is a continuous graph where there is no break or jump at all. And all the amplitude, compression, wavelength, everything is calculated based on the graph, which is continuous in nature. Here, this is one of the application of continuity. Next, the main topic, ordinary differentiation. So, what do you mean by differentiation or ordinary differentiation means? It is nothing but a rate of change. Rate of change of something, process is happening in a particular time. there is a change happening. That is what differentiation concept is all about. If you want the definition, it is a process of finding the derivative which represents the rate of change. Now, the function depends only on one variable. So what is the difference between, we will be discussing partial derivative next. So ordinary differentiation is nothing but, it is a rate of change but only on one variable. But when we go to partial, it will be more than one variable, we will discuss later. So first, understand that ordinary differentiation is nothing but only on one variable. Okay, so this is the pictorial representation where we are just throwing something. There is a rate of change in the trajectory and it is calculated using differentiation concepts. So what are the rules of differentiation? This is the basic fundamental of finding a differentiation. Okay, so first we have to understand these three rules, then only we will be able to differentiate a simple function. First, the important rule is power rule. You already know in the lower classes, d of x power n or d of x power n by dy by dx of x power n, where we are going to, how do you use the power rule for x power n? Differentiation of x power n is nothing but n x power n minus 1, right? So that is the basic fundamental, we have to understand that rule, power rule. Other important rules are sum rule, product rule and quotient rule. Sum rule is nothing but where we have two functions and we are going to differentiate two separate functions, and there is a sum in between, then differentiation happens individually. Like there is a function f of x and g of x, you are differentiating with respect to x. How we differentiate? F dash of x plus g dash of x. We will give the examples afterwards. Now product rule, when we are going to differentiate two functions, that is in multiplication. When we are differentiating uv, u is a function, v is another function, differentiation will give you have to differentiate by keeping u and differentiate derivative of v plus v into derivative of u. Next is the quotient rule, where how to differentiate when the two functions are in division, like differentiation of u by v, where u and v are separate functions. Okay, so these are some practice problems. We'll discuss how we are going to differentiate this. This is under sum rule. How we can identify that there are separate function which is distinguished by a plus symbol. So we are going to individually differentiate, which means differentiation of x power 4 is nothing but 4x cube plus 6x plus 0, because 9 is a constant, so you will get an answer like this. Next we have product rule. Product rule, what was the formula? Differentiation of uv is nothing but vu dash uv dash plus vu dash, right? Where u and v are this, you can consider this as u and this as v, and find the derivative and substitute in the formula, which will give you what? X u is nothing but x square into differentiation of x plus y is nothing but 1 plus v is x plus y into u dash. Differentiation of u dash is nothing but 2x. And simplify this, we will get what? X square plus 2x square plus 10x, which will get you what? 3x square plus 10x. Okay, so this is how we use product rule. Next we have quotient rule, where we use quotient rule when the two functions are in division. This is, you can simply say u by v rule. What is the formula for u by v rule? It is division, you have v square u dash v minus v dash u. Okay, so how we explain that? V dash u minus v dash u, this is equal to what? This is u and this is v. U dash is nothing but 2x into v is nothing but x minus v dash is 1, u is equal to x square plus 1 divided by v square. What is v square? X square. Now it is 2x square minus x square plus 1 divided by x square. The final answer will be equal to x square plus 1 by x square. Understood? So this is how we explain the three important rules for understanding the ordinary differential equation or ODE. Okay? So we move on to the next topic, which is partial differentiation. Ordinary we already discussed. Now we are going into the partial differentiation. So what is the difference? Already we said what? Ordinary differentiation is nothing but when you are differentiating only one variable. Now when we come to partial differentiation, when the function depends on two or more variables. When it is more than two or 2, you have to use partial differentiation. And how in ordinary differentiation, we would have used the symbol, this D, right? Now we are going to use what? For ordinary differentiation, we will be using D. For partial differentiation, we will be using the symbol DO. Okay, so understand the differences. For partial differentiation, it is more than one variable, and for ordinary differentiation, it is only one variable. Okay. So when a function depends on 2 or more variables, we use partial differentiation. Finding the rate of change concerning one variable while treating the others as constant. This is also important. When we are treating one as one variable, all the other variables, whether it can be y, z, anything, you can have to consider it as constants. Okay, so this is the definition. Next, this is a diagram for representing how we represent partial differentiation. The golden rule of partial differentiation is differentiate one, freeze the other, which means we are going to differentiate what we have said. Partial differentiation means it is more than one variable. So we have 2 variables here, x and y. So if we are going to differentiate with respect to x, then we are going to consider x alone and keeping this other than x as constant. That is the major rule you have to follow in partial differentiation. Similarly, when we are going to differentiate with respect to y, treat all the variable other than y as constants, where even though it is an x or z, anything, you have to consider all the other variable other than the variable that you are differentiating as constants. So with respect to y, x is constant. With respect to x, y is constant. Understood? You have to treat those other variables exactly as a constant. Okay? So this is what you have to remember while differentiating partially. These are some problems based on partial differentiation. If you understand ordinary differentiation perfectly, partial differentiation is very easy. Okay, so just look into this solved problem. It is nothing but how we use sum product and quotient rule in partial differentiation also. Here this is a function x square plus y power 5. Differentiating with respect to x, this is what it is very important. With what you are going to differentiate? With respect to x. So you have to write what? Dou f by dou x, because this is our function f with respect to x. You are going to differentiate these 2 functions with respect to x. So with respect to x, all other variables, which is y, should be completely treated as constant. Which means if y is like constant, x square with using power rule you get 2x. Y power 5 completely it becomes 0, because differentiation of a constant is equal to constant. So answer is 2xy. Same way with respect to y, consider x as constant. So x square is completely constant with respect to y. Y becomes 1. So the answer is x square. Y power 5. Now this is not a constant because we are differentiating with respect to y. So y power 5 becomes 5y power 4. Understood? So it is very simple. So try to understand it from the basic golden rule that you have discussed in partial differentiation. Okay. Next, this is we already discussed. What we have discussed in ordinary, the same rule applies for the partial as well. Only the symbol changes. The rule is applied in the same way. The symbol changes, like instead of d we will be using do. Okay. And remember the golden rule. Okay. Next, this is the next final rule. It is chain rule. Chain rule is nothing but if use a function of t and t is dependent on x, y, z, which means we have to use chain rule here. Okay. So how we use chain rule? Dou u by dou x is equal to du by dt. Why we are using du by dt? Because u is dependent on only one variable. So only one variable means we will be using ordinary differential. Next, t is dependent on 3 variables. When more than one variable we will be using partial. That is by dou. Okay. So understand the formula. Don't make a mistake in the formula part. So this is how chain rule works. We can understand perfectly when we discuss one example. That is enough for you to understand. This is our final example for the session. Just listen carefully. We'll completely understand how the chain rule works. Okay. So given z is equal to x square plus y square, we can use a map. Z is a function of x and y, but x and y are functions of what? T. So what he has said, z is dependent on x and y, which means we are going to use partial differentiation here, and x and y is dependent on only one variable, which means we are going to use ordinary differentiation here. That is the only understanding you have to get when you are looking at the functions. Okay, so we are going to find dz by dt. Remember the formula, dz by dt is equal to dz by dx dou z by dou x into dx by dt plus dou z by dou y into dy by dt. This is how the formula you have to frame. Next, easily you can find dou z by dou x. What is dou z by dou x? X square becomes 2x. Dx by dt with respect to t it is 2t. Dou z by dou y, x is completely constant, y square becomes 2y. Dy by dt, 3t becomes into 3. That's all. Just simplify this, we'll get the final answer. This is like 4xt plus 6y. That's it. Okay, so this is how we are going to use the chain rule, so that we can, even when there is more than one variable is dependent on inside the same function. Okay, that's all. So we have reached our end of the session. Just we have to conclude what we have studied today. Limits and continuity. Limit and continuity is nothing but limit gives you the value of the function where it approaches. Continuity, it understands whether the function is smooth or not. Ordinary differential, when the function is dependent on only a single variable. Partial, when there is more than one variable, two or more variables. Okay, that's all. Hope you have liked this session today. Thank you for your listening.